Hello and welcome to Pentest blog. Today we are going to see how to bypass ASLR protection that is applied to a binary. So the ASLR stands for Address Space Layout Randomization. This is an exploit countermeasure introduced on an operating system level. So when an ASLR is turned on, upon launching a new process, its core memory areas will be loaded at a different address each time. The ASLR setting is held in a file proxys kernel slash randomize underscore v underscore space. So today we will see this is a simple bypass on ASLR. So we will see this on Ubuntu 16.04. So you can download the 16.04 in here, like releases ubuntu.com 16.04, and I have downloaded through this torrent file. You can also download this torrent if you want to download with torrent. And then I have installed gdb peda upon dbg and jeff all at once from this github repo. So we have already discussed this in our previous videos, so you can watch our previous videos as suggested at the top. First we will introduce the program. This is the same program that we are using from the beginning. Yesterday we have bypassed the NX enabled, that is an NX bit, and today we are doing the ASLR bypass. So this is the same. If we review the code, we are initiating a variable with 500 byte size, but we are reading a size of 700 into. So there is an stack overflow. So let's see on an operating system level, like if we see the ASLR bit cat proc this and then kernel randomize, and we can see the value is 2. So basically there are three possible values, 0, 1 and 2. So if this value is 0, then the ASLR is disabled. If the value is 1, then it is enabled. And if the value is 2, then the SLR is enabled. In addition to 1, the data segments are also randomized. So in our case it is 2, that is the data segments are randomized, and this is as expected. So we will check how the address randomize itself. So what we can do is the same is here, like LDD in thing, and we can see this thing, the address is P7DC, and if we do it again, the address has been changed, right? So we want this thing, so what we can do, like copy and LDD grep, and you can see the address has been changed again. So every time a binary is being loaded or a library is being loaded, the address is changing. So to get an idea of this, we can, so what we can do, like, so first we will do our previous command, this thing, and now for I in, we will use the for loop sequence 1 to 10, and what we will do, LDD, and we will do the same thing again from here to here, copy, okay, LDD, this thing, and then we would cut the result to cut minus d, and our separator will be a small bracket. That is, we want to cut it here. So this will be our first part and this will be our second part. So, and now we want to select the field second, that is this part, and we want to remove it, so we will give it to tr, and again this thing, and we want to replace it this, and done. So as we can see, the address is being changed every time the binary or the library is being used. We can compile the code. So here is our vuln.c cat. This is our code. So what we will do, like gcc -f no stack protector vuln.c -o. We want the one, and now we have the executable. So we will load it into gdb beta, and it has been loaded, and we will set a breakpoint on the main function, and now we will run it. We will hit the breakpoint. So what we can do, vm map, as we have discussed earlier, and we want the libc address. Okay, so every time we are okay, we will run it again. So we can see like it's b7e0 8000. We'll run it again, and b7e0 8000. So it's not randomizing the address, because gdb by default disables the randomization of address. So what we can do, like set disable randomization off. We will, and then we will run it again, and map, and it has been changed 7db2000, and we will run it again, and map, and the address has been randomized. So now it's working. So we have seen like how the address is being randomized. Now we will recap our payload from previous classes, and for a quick recap we will generate an exploit.py, and first thing that we will import is this, because we will use python 3, and buff equal to, and our offset was 516, buff plus is equal to p, that is 4 times p, and this will be, and this is our system call, that is the EIP. The second is, we will just copy paste, and sys dot std out dot offer dot write and off. So what this thing, this, and this will be the command where we want to jump the code, and this will be the return address, that will be exit function, and this is the parameter to the function calls, system function. So it will be bin as we have seen it earlier. So for clear path, in the variable, and since this is okay, the bytecode goes here and it's ready. So what we can do, like I have another terminal here, python 3 exploit.py, and it's so now what we will do is got an idea like how the address is being randomized. So from here we can start our like a exploitation process. So as we have seen, the address of, so let's, as we see that this part is fixed and this part is fixed, so only these two bit is changing. What we can do, we can easily brute force these two bits, and using that we can exploit the ASLR. We want the libc base address, so we will load it. And again, remember, like every time you start the GDB, you have to disable the randomization. And I want to make a breakpoint in main and run it again, and pm map libc, and we can see this address. So this is our libc base address. As you can see, this address is executable. The xbit is here, so we will use this thing as our base address. So what we can do, and we have to like pass this address in little endian format, that is in reverse order. So instead of reversing all the address, what we can do, we can we can use the struct function. We can use the struct library, and libc base this thing, and now we want the system. So as seen earlier, we can print the address of the system. So this thing goes here. Now what we can do, print this minus our base address, and what we can do, like this thing, and system is equal to libbase plus this thing. Now what we need is the return address, that is the exit function. So libc plus, so now we will print the address of the exit, and we will minus it from here, and this is the exit. That is our payload. And system is this will be this exit, and this will be sys r, that is libc base. So to find the we will pass argument. We will pass bmsh as the argument to the system first system library. So for that we have already seen find bin feda, and it will give us we will use this address and we will minus it again to get the difference, and this thing we can add it here. Right, so now above is this. We will remove the we will comment out this thing. Now what we'll do, like above is equal to struct back, and the first thing will be this system. Okay, and this will be plus is equal to copy it. The second will be this exit. The third one will be this R, and we will print the buffer finally. So now if we run this Python 3 exploit.py. Okay, so a structure in Python 3 there should be a byte thing. So and it's working actually. So what we can do, we can save it to payload.txt. So this thing, and now what we can do, we can use the cat functionality. So this is like cat. Okay, we will use start with bracket cat payload.txt echo id. We want to process an id command, and echo we also list the directories, and we will pipe it to all. So there will be segmentation fault, and as we have seen, this part is fixed and this part is fixed. So we can brute force this middle 2 bits. We have set it to cc for this purpose only. You can set here anything. So now what we can do, like while true and we will use the same cat command. Okay, and we will grab the uid and then and done. Let's see, and we can see like our uid, the first thing is id, and we are listing the directory. So our cell has been executed, and we can see there are 2 times the cell has been executed. So this is all. This is how we can bypass ASLR. This is a very basic bypass in today's and this is very old operating system, like it is Ubuntu 16.04. So as I have shown you, you can download it from here and do your practice following my video. Please like, comment and subscribe this video so that we can make more videos like that, and please let us know how you feel about this video in the comment section. Keep hacking. All the best. Bye bye.